Hello student. Today we start with linear application of op-amp. Before that we see some linear and non-linear applications. In case of linear application, these are sign changer, adder, subtractor, instrumentation amplifier, integrator, differentiator, and log and anti-log amplifier. Now in case of non-linear application, there is comparator, zero crossing detector, amplitude distribution analyzer, window detector, Smith trigger, precision half and full wave rectifier, sample and hold circuit, clipper and clamper circuit. In 12th standard, we study the nonlinear applications as comparator and Smith trigger, while in linear application we study with sign changer amplifier, adder, subtractor, integrator and differentiator. Now let us see the linear application of amplifier, in which we see first is op-amp as inverting amplifier. Now in case of inverting amplifier, the non-inverting input of op-amp is connected to ground, while input voltage it is given to the inverting terminal of the op-amp. Here the Ri is the input resistance, Rf is the feedback resistance of op-amp. The output is 180 degree out of phase with input, hence the feedback signal is out of phase with input signal. No current flows into the input terminals. The differential input voltage is 0 as V1 is equal to V2, where V2 is ground, that is virtual ground. Then by using these two rules, we can derive the equation for calculating the closed loop gain of an inverting amplifier using first principle of the op-amp. Now here let I be the input current, which is equal to V in minus I be the input current which flows through the resistive network as shown in the diagram. Now from this resistive network, we write the equation I is equal to V in minus V2 upon R in is equal to V2 minus V out upon Rf. Now rearranging the terms, we write V in upon R in is equal to V2 in bracket by taking the V2 common, 1 upon R in plus 1 upon Rf minus V out upon Rf. Now we know that V2 is equal to 0. Therefore, V in minus 0 upon R in, it is equal to 0 minus V out upon Rf. So, Rf upon R in is equal to V out upon V in. Now, the equation of the output voltage V out also shows that the circuit is linear in nature. The equation is V out is equal to minus Rf upon R in into V in. Then the closed loop voltage gain of an inverting amplifier, that is AV, it is equal to V out upon V in, which is equal to minus Rf upon R in, where negative sign in the equation indicates an inversion of the output signal with respect to the input, as it is 180 degree out of phase. This is due to the feedback being negative in value. The equation of the output voltage V out also shows that the circuit is linear in nature. Now we see the virtual ground concept, which is shown in inverting amplifier. So according to the formula, the gain is given by the equation V out upon Vi, that is V in or V in. As we know that open loop gain of op-amp is infinite. It is the important characteristics of op-amp. So the gain, as open loop gain is infinite, so V in is equal to 0. But we know that V in is equal to V2 minus V1. In the inverting op-amp circuit, V1 is connected to the ground, Therefore, V1 is equal to 0. Thus, V2 will also be at ground potential. So, we know why we need that virtual ground. We see this virtual ground concept is very useful in the analysis of an op-amp where negative feedback is employed. It will simply a lot of calculations and derivations. Means due to virtual ground concept, the lot of calculations and derivations will be easy to simplify. In op-amp, the term virtual ground means that the voltage at that particular node is almost equal to ground voltage, that is 0 volt. It is not physically connected to ground. Now let us see the comparison between virtual ground and real ground. We know real ground. In case of real ground, here the terminal is physically connected to the ground or earth, which act as the reference point for the entire circuit. That is real ground. But in case of virtual ground, it is the concept that made for easy explanation and calculation purposes. Now in case of virtual ground, voltage is approximately 0. While in case of real ground, the voltage is 0. Now in case of virtual ground, it is not able to sink infinite current. That is, in case of virtual ground, voltage is 0, current is also 0. But in case of real ground, it is an infinite current. In case of real ground, it is an infinite current sink. Means voltage is equal to 0, current is equal to infinity. Now in virtual ground, it is not electrically connected to ground. In real ground, it is electrically connected to ground. Now virtual ground concept is valid only when negative feedback is applied to op-amp, like in inverting amplifier. So thank you student. In next lecture, we see next application of op-amp, that is non-inverting amplifier.